Hello, I'm Angus at LabVac. Up on the bench in front of me I have got a very, very rare thing indeed, a pump that I have never worked on before. So this one should be fun. This is a Agilent DS40M, which is a tiny little, it's about 2 cubic meters an hour, two-stage pump. And it's the first one of these that I've seen. Now the M in the name tells me that this has a magnetic coupling, which makes it even more interesting. I've done quite a few of the magnetic coupled pumps from Agilent Varian, same company, but not this particular one. So we're going to get into this. Procedure-wise, I am going to start by taking the drain plug out, purely because it sticks out a long way. And what I really want to do is flip the pump up on its end, like that, so that I can get to the underside of it. So, base plate off first. Grab some empty pots to put the bits in. I do like to put the bits in a pot so I can find them again later. There we go. That's the base plate off there. I'll put the other screw in. There we go. And then the motor itself, I've got 4 bolts on here. Now these magnetic couplings, fantastic idea. Basically you have a magnet attached to the motor and a lump of iron attached to the pump shaft. Might be the other way around, we'll see. But the rotation of the motor then induces the pump shaft to turn, but they're completely isolated from each other. There's no contact. As a result of that, you don't need to seal a shaft because there is no shaft travelling through. So the motor, I'll just come off there, you can feel as I'm trying to lift it, the magnetic coupling is resisting me, so it takes quite a bit to tug that off there. So there you go, there the magnet sitting there. So this spins around and there's nothing here coupled to it. So there's no shaft running through, so there's no shaft seal, so there's no oil leak. It's a great idea. The rest of it we'll see inside. This cup here, on the inside of that cup is the iron that's attached to the shaft of the pump itself. So that's the motor out of the way. I'm just going to get this handle off as well, because it's a pretty hefty handle really for such a small pump. So let's take that off there, get into the oil box. Just 4 screws. And interestingly, the reason I paused there for a moment, the 2 down here at the bottom are recessed, and the 2 at the top aren't. And I'm looking at that and thinking, maybe they're not doing the same job. But I think they are. But I have lost track already of where I'm putting the screws. So. I've got a lot of benches full of dismantled pumps at the moment, waiting for the go-ahead to fix them. So trying to keep all the parts separate is quite important. There we go. But this is a dirty pump. Look at that. Oil box off. That is going to take a bit of cleaning. There's our interior, which is quite a complex one. The pump cartridge is held onto the adapter with these three long bolts that run right the way through. So the first thing I want to do is take those off, separate the cartridge from the adapter, and we'll be able to break it down from there. So with those out, there should be nothing else holding this down. Oh, but the pump has decided to come apart first. There we go. Okay, so when we looked in from the other side, that's the cup that we could see. Okay, so there's an O-ring behind that stops oil leaking out past there. And then this is what we see on the inside. This is what's actually attached. So when the two go together, that will be sitting inside there. You see the magnetic pull. So when the motor spins, it causes this to spin. And that's what drives the pump. Nice little design there. And then that's our cartridge. Got bits and bobs falling out of it, so I'm not going to force it back together, but that's how it would come out. And then the next thing we would do is separate it, so let's go ahead with that. So we had a long dowel pin that came out there. Got a washer there, which I think is off one of the long rods that got left behind. There's probably two more stuck back there as well. And then the usual series of O-rings. I like a nice pile of O-rings over there so I can see what I've taken out. And then there's a piston here, which has come partially forward, but is rather stuck. Let's see if I put some air behind that, whether that'll pop it out. It did. There we go. So under there we've got a spring, which I believe is a gas ballast non-return. Down there, there's another O-ring tucked in at the bottom there. It's going to need to be picked out of there to be replaced. Okay. This pump is very sticky, as you can see, and I'm wary of digging in too hard to get these seals out if they're gummed in there, because the result will be with a metal pick I end up with scratched surfaces, which I would really like to avoid. So some of these I may have to come back to in the cleaning process, because once they've been boiled up in some solvent, they'll come loose. They'll have no choice. So to remove the drive element there is a very small screw, which hopefully I can get at. A lot of my tools are currently in use on other jobs, so I may have to go ferreting around to find things. But hopefully I've got sufficient here to show you this. So there's a very small screw there that's coming out, and that is what's holding this drive element onto the shaft. So you can see the shaft is cut down, fits onto there. With that removed, the rotor will now push out, but again on this particular one it's pretty sticky, but there we go. That's out of there, and we've got a shaft seal in there, which again is going to be a tricky one to pull. These vanes don't have any springs with them, although interestingly the vanes are not drilled for springs, but the rotor is. So I'm thinking maybe there's more than one variant of this particular model. So back to the rest of the pump cartridge here. We've got a baffle plate across the top. If you've worked on pumps or watched any number of these videos, which I know you haven't because people only look for the pump they've got in front of them, a lot of these things will start to look familiar. It's another one of those washers for the long rods. And one of the things is dowels. So there's the second dowel. Those dowels ran through there and there, what's holding these parts together. It's our final rotor. I need to take the end plate off here. But on this section here, which is sort of the end plate for the first stage and the stator for the second stage, we can look in at the top here. We've got a valve underneath this plate. These are all just crosshead screws that I'm taking out. Or attempting to take out. But they are very small, so really like to not lose any of these. Grab another pot. And you can see that there's a stud on there that sits into the spring, and under the spring is the valve pad itself, the rubber part on the exhaust valve for that stage runs through there. We've then got a couple of oil ways here, oil ways or air passages, could be either, that need to be taken out. Another gnarly screwdriver. And underneath there is an O-ring in each case. So the O-rings will need to be picked out of there. Added to the pile. And that's everything off that section. We've also on the first part got another valve there that I haven't taken out. Well, let's move to the final stage. So that rotor, we can remove the vanes, which again, no drillings, no springs in there, but again there is a drilling through the centre of the rotor. I guess that could be just for oil circulation, but I can't really see where that oil would be coming in from, given that the hole only goes through. It looks like it's a spring support hole to me. So we've got now 1, 2, 3, 4, 5 screws in the end here, which are clearly in 2 sets. So take those out. What I haven't seen yet is an oil pump, so I'm assuming that underneath here we're going to have an oil pump. And indeed we do. It's tiny, but there it is. That vein in the centre there will be picking up oil, pushing it out, circulating it through. So that should now release the rotor. And then the vein for the oil can come out of there. got another shaft seal here and an O-ring. That shape only comes from the groove that it's been put in. It will be a regular O-ring, not a formed part. And then these two holes are where the dowels line up. And then finally, take those last two screws out, and then there we go. So the oil pump then just separates from there, and that's all our sections broken down. So the only things that I haven't done, there's a few O-rings that need to be picked out, and this final valve, which I'm assuming will be identical to the one I just took out, but let's have a look, just in case. Yeah, exactly the same deal, rubber pad spring. This has got some really bad contamination in there. Also got a section up here which runs from the inlet, which I would think, looking at it, is just a machining port. When the pump is manufactured, you often find that in order to drill certain positions in the pump, they have to make additional drillings that then aren't needed, so they'll be capped off, and you'll see it done in different ways by different manufacturers. Sometimes they have, if they're small, they'll have just some epoxy run into them and allowed to set solid, and that's sufficient to seal the port off. Sometimes, as I think is the case with this one, they actually put a thread in there so you can put a solid cap into it. What I'm searching for here while I'm talking is, again, missing tools because we've got too much work on. Yeah, so you can see different ways that these things get capped off. There it is. Personally, from a service point of view, it's quite nice if you can open these things up, because it often, there we go, we can. Yeah, so that plug unthreads from there, and there is another O-ring there, so we're going to want to change that as part of the service. But it also means this gives me much better access to be able to clean down through. For example, if I want to put a brush through the inlet here, which is coming from here, there's a right angle there that I can't get to, but having opened that port, I can now run a brush all the way through there. So I'm going to end up with a much better service job because of having access through there. So yeah, I kind of like it when you can open those ports up to get access. That's a filthy pump. That's going to go away for a lot of very thorough cleaning, and then I'll come back and show you the reassembly. Okay, so we're back with this DS40M from Agilent. Everything cleaned up pretty well. I was quite pleased, given the condition that it was in. You'll remember, covered in that sort of brown gunk. That's all washed off reasonably well. Took a bit of effort, and it's now 2 days later, but here we go. Didn't take 2 days to clean it, but had a few other things to do. So I've gone through the kit, which essentially is a vast number of O-rings, all of which looked very much the same, but were all slightly different. So I've actually gone through and sized them and fitted them before turning the camera on. Otherwise, it would have been a long and dull video. Not to say it's not already a long and dull video, of course. So I'm not going to take all the O-rings out, I'll point them out as we go through. What I haven't done is fit the shaft seals, of which I have two. So I've got one there that sort of seals the oil pump side of things, and this is our inner shaft seal. Although bear in mind, being a magnetic coupling, we don't have an outer shaft seal, so I've just got those to pop in. The way that I do this, it's not the only way, but I don't use a press. I find that setting up a press I do have one, but it just takes a lot of time and is more than necessary. I use these very cheap and cheerful seal drivers, bearing drivers, they might be labelled as. You can buy them from pretty much anywhere. Basically choose the size that fits the seal and give it a whack with a hammer. So I'm using a dead blow hammer. This has shot inside it to give it an extra bit of oomph. I'm going to do it on another bench because I don't want all of those tiny screws to go flying if I whack it on that one. So once that seal in place, just refit that O-ring. This is one of the ones that isn't a perfect fit, but does do the job. So there we go. And then the inner shaft seal is going to go there. It's going to need a larger size driving piece. One of the things you can do, these seals will go in really easily if they're completely flush and true. If they go a little bit over to one side, then they can be a real pig to get straightened out. So what you can do is use an oversized driver in the first instant. That will push the seal down into place and land up flat against the metal surface. So you know then that it's completely true. Then you can go in with the smaller size and drive it all the way home. So I'll just do those. That was a tight fit. Just put that O-ring back into place. There's also an O-ring up in here, so I've fitted a new one there, which has jumped out from the hammering. So that sits down behind there. And then while we're on the subject, I've got our little piston, which turned out to be brass. You couldn't tell that underneath all the muck. The spring goes in the centre, then there's a very small cross-section O-ring that sits there, and that will drop down into there. It's quite a tight fit, but it does move, which is what it's supposed to do. So that's that section. And that's down in there nicely. Okay, so that's the shaft seals done and the piston in place. I've got an O-ring that's fallen out there. We'll have to figure out where that goes. It sits up in the top there. And while we're looking at that, we can put the plugs in. So I've got new O-rings underneath those. And then these are the plugs with the conical ends that came out. These, if you remember, are passageways. They're machining passageways. They need to be sealed up tight, so new O-rings in there. And then nip those up. When things are sealed with O-rings, they don't need to be fantastically tight. don't need to screw these things in incredibly tight to make sure they're nipped up firmly so they won't back off. So that's those two, and then back on this section there was also one, the O-ring for which seems to have warped. There we go, it fell out while I was knocking the seal in. So that goes there, and this is the very flat, low profile one, which will go in there. And again, just nip that up. Okay, that's all the plugs in place. So I'm going to go back over now to the adapter plate. I've fitted a new O-ring underneath here, which is the inlet valve assembly. That one was particularly difficult to get in place. Then attached to that we have this rather fetching cross piece. Now this is very pokey-okey. You can see that one lug is thicker than the other, so it will only go in that way round. It does have drillings through it, so obviously the size and position of those drillings is important. So that sits down into there, and then there is a little piston with a pad. That will be what pops up and closes off the inlet when the pump's not running. So that sits underneath, and then there's a second block that sits over the top of that, and again is shaped so it can only go one way round. There's a little lug there that holds it, and then that's held in place with, there they are, some very fine machine screws, which use a 2.5mm Allen key. So you really don't want to be putting a lot of torque on these screws. Let the O-rings do the sealing, because even though it's a high quality fastener, they're going to round out fairly easily. Anything with that small of a tool is susceptible to rounding out the heads. Call that good. This screen in the centre here, again, it cleaned up pretty easily, which is good, because I couldn't figure out how you actually take that out without damaging it. You know, you can push a tool through it, but the chances are you're going to rip the mesh. Another one of the O-rings that, to my mind, could have been 0.5 mm larger in ID. I did have it fitted, so it will go in again. There we go. And then there's a top plate / inlet flange that sits down on top of that. And we now need a 4mm Allen key. So the tool count's pretty high with this pump. So that's the inlet taken care of. So I flip this over. We had a few O-rings here. There's a new O-ring there for the oil box seal, which is one of these that you have to feed in and twist and turn and get it into place. And then it's not a bad idea, once you've got that into place, if you're doing it in advance of assembly, just sit the oil box on top of it to hold it down while it sort of takes the form. Then we've got an inlet O-ring here and another one here for the seal that goes onto the back of that brass piston. So those are all in place. And now we have the age-old debate of, do we assemble the motor up to here and then build the pump onto the motor, or do we assemble the cartridge first and then put the whole thing together? My normal preference is to assemble the cartridge first, because then I can get hold of it and turn it by hand and make sure I'm happy with that it's moving smoothly. Particularly significant with the magnetic coupling, because once the coupling is put into this cup, you can't access the back of it to rotate it at all. So I'm going to assemble it that way. If we run into any issues, then we'll come back and change that. It's handy to sit drop the cup in. There is a new O-ring behind that cup. It's handy to use the adapter just to hold this, because it means that when I put the shaft through, it's not going to hit onto the bench, it will actually fit through. So got my 2 vanes and rotor. Just going to check. Yeah, I think you can put those in once the rotor's in place, so we'll try it that way first of all. So assembly oil, lots of assembly oil. It's just the regular oil that you're going to put in the pump at the end. You just want to pre-lube everything. And then lower that carefully through the shaft seal. Once it goes through, give it a bit of a turn, make sure it's sat through right, and that will sit down. The thing with the very small pumps like this is there's not a lot to grab hold of. The larger pumps, you big chunks that you can grab hold of to turn them. This is a little bit small. So I cleaned up the vanes as well, just with a bit of Scotch Brite, and then honed off the front faces. But they were, underneath the goo, they were pretty good. They do have, well, you can see that, it's probably difficult, but one of these faces is completely flat and the other is curved. And the curved face obviously is designed to sit against the stator. We'll just make sure that they go in the right way around. There's no springs in these, as we said earlier. And we can move on to our second stage here. So I've made sure that I've got seals where I should have seals. Okay, all those faces, and make sure that there's some oil in the bore and around the shaft. Lower that into place. Now that's going to be lined up by the dowels, which sit here and here. So I'm just going to place that on, and then take a dowel. Again, a little bit of oil in it to help it to move through, but it should push in smoothly. I can just feel that catch. So that means I now know that the orientation is correct. And on to the next section. So the next section has the O-ring on here, which is going to face onto there. So that needs to turn over, and it's going to fit that way up. Plenty of oil in there. And again, probably too small for you to see, but there is an O-ring in this face here. One small one there. Would help if I put the rotor in next, actually, wouldn't it? See how easy it is to completely overlook something so fundamental. So pop that in there. pair of vanes. Quite like how you can drop these little vanes in once the rotor's in place. With most of the pumps you have to fit the vanes because they have springs through. You have to fit them in place first and then compress the springs while you fit that down. So it's a little bit easier doing it this way. And then the two dowels have got to line up there. And we've got a shaft seal there, so we've got to go gently ease that shaft through the seal. And then pick up the dowels. And there we go. We're moving forward apace. So then up onto the end of here I've got the oil pump, which has been thoroughly cleaned, but things left out on the bench like this do tend to pick up a bit of dirt as they go. So this is going to sit onto here and it's going to be orientated by the through screws which sit here now. I'm reminding myself as we go, as you can obviously tell, but that's our outer plate which is going to pick up on those screws. So the ones I'm looking for on here are these two, which is going to orientate the piece like that, which makes sense because then my slot here lines up correctly. So that's going to go on there. So I'm just going to get a bit of oil on the back of there. These won't be moving against each other, but the oil will help to provide a bit of a seal. And then I have 5 screws that hold this assembly together. Got 3 the same length, 2 short ones, so they're going to be the ones that I want for this. Just get those started. I'm going to welly those down because I also have the oil pump vane to fit in there. So I may need just a little bit of give in that plate to get that into place. That looks good. And then again, I need a little bit of rotation left here to be able to fit the cover. So to cover these 2 large holes here are going to sit over these screw heads. So again, oil up the surface that's mating, and then if I've done it right, that should sit over there, leaving me the through holes for those last 3. And then I think, yeah, we haven't used the 3mm Allen key yet, have we? So let's try that. Make sure you buy the full set, folks. Okay. And then I'm going to go through and nip all of those up. See if you wind any one screw in first, it can make it difficult to get the remainder in, so bit by bit, a little bit of patience, work your way around them. So that's the main part of the cartridge built. The remaining items we've got does not sit in any way usefully for my purposes, but there we go. So we've now got the valves to fit onto the top. This is not tight together yet. You can see there are gaps between because it's only held by the dowels, so I could knock those together with the mallet, but when I go ahead and put the through bolts in, they will draw it all together anyway. Now at the moment I'm not able to turn that partly because I can't get any purchase on it because it's so small, but also because there's a slight misalignment because of these not being placed together. So I'm going to need to test that to make sure that that runs smoothly when it's closed up. I'll go ahead and fit the valves. They're not going to make any difference to the alignment. So the valve pads themselves sit down in there with a spring, and then the support bracket needs to pick up that spring and then the absolute tiniest screws. I'm sure whoever designed this must have gone to stores and said, I want the smallest screws you can possibly give me for this, so that the service engineers lose most of them. I've got pretty big hands for doing this job. So again, I'm going to nip those up. I'm slightly in terror because those screws are so small. Putting too much torque on them, and a tiny fastening like that is going to give, I think, fairly easily. So great caution. It's probably also making it difficult for you to see what I'm doing. My great big hands are covering over such a small part. There we go, we've got them in. Okay, so that's built up. Before we go any further, I am going to give that a little bit of a tap. Just move that O-ring back over so it doesn't disappear. I'm going to give this a bit of a tap to bring the dowels in, just to so I can check that everything is moving smoothly. Okay, that's sat down tight, just with that little, one tap here, one tap there, just to push the whole thing together with it sitting on the bench like that. And I can now turn this by hand. It's still difficult because it's so small, but it's there. So I think we're all right from that point of view. And to double check, we can now fit the magnetic component to the coupling. You can tell it's magnetic, can't you? Everything's attached to it. Just want to give this a little bit of an extra clean because I've noticed that I missed a couple of spots where there's still some of that gunk. This is the one part that I haven't put through the ultrasonic bath. Again, I'm sure it's robust, but I wasn't going to take the chance, so this is only getting clean by hand. But I will put a bit of solvent through it. I want to reintroduce any of the muck that we just spent 4 hours cleaning out, all because one component got overlooked. Okay, I'm going to call that good. So that now sits down and it aligns with the slots, so it sits solidly on there. And we've got a washer and another tiny screw which has an even tinier split washer, spring washer, call it what you will. And I believe I'm going to need a smaller screwdriver. You would think that these very, very small pumps, the sort of 1-2 cubic metre an hour pumps, would be the easiest ones to work on because of their being so small, but they're really not. And the reason they're not is because the components you're having to handle are so small. You also find that the smallest of the pumps are the ones that can be slightly slow in catching their final vacuum. When you've serviced them, you put them back together. Larger pumps with the extra flow rate tend to overcome any issues that they have more readily than the small ones. So that's everything built up. So at this point I want to turn it. I'm only turning in the direction that it would run. Obviously the inlet's here, so the rotation is in that direction. So I'm just going to give it quite a few rotations. Make sure it's perfectly smooth all the way around. It's not catching anywhere. It feels good. I'm not hearing anything happening. Most pumps you would hear something happening, but I think that's because it's not tightened down fully. So we've got a cover that goes across the top of the valves, which sits in there. That acts as a baffle so that the oil that's coming through the pump is partially contained and drops back down. It also, in many pumps where you see that, it catches some oil and creates a sort of swimming pool of oil over the valves, but only of the correct prescribed amount. Just keeps everything lubricated, and in some pumps it actually assists the valves in not opening too soon. Right. Might go and work on a car after this with big parts, big tools. There we go. That's the cartridge assembly completely put together. So to finish off the pump, there's a few more parts on the bench, so let's just address those. I've got the outlet flange, which again, new O-ring. That's just going to screw down on there. And as I always like to say, it's O-ring sealed, it doesn't need to be super tight. There are flats on this flange, but they are for disassembly, not for reassembly. So hand tight against the O-ring is good enough for that. Fill port, again, same deal. In fact, there's no flats on that anyway. The sight glass on this was something that I haven't come across before. It's a plastic sight glass, yes, I've seen those. They come on quite a few pumps, use this sort of bullseye type. But normally they're on a thread and they screw in with a washer behind them. This one is literally sitting in this rubber seal. And the whole thing just pushes in. Apparently that's enough. So here's hoping. I did try to clean this because I didn't have a replacement in the kit that I've used, but I wasn't able to clean it. Whether you'll be able to see anything through it once it's put together, I don't know. Might be best to put the seal in first. Pop that out of there. Get the seal through. A bit like putting a cable through a grommet. Yeah, so then we've got the sort of bullseye thing in the centre, and this is obviously, this is polycarbonate or whatever, and it hasn't stood up to whatever's gone through it very well at all. But short of replacing the part, there's nothing I can do about that. That's gone all the way through, so we're going to have a second stab at that. Go number 2. Alright, I won't waste your time, I'll come back to that. I'll figure it out off camera. Drain plug, more conventional and straightforward. And that's ready to go on. So we can now fit the cartridge to the adapter plate. Double checking that our O-ring's sat down in there. Cup sits through. O-ring's in place up here. And then this whole thing will drop down. There's one dowel, one solitary dowel there to align the whole thing. And then our 3 bolts. So pop that down again for a second. I need to fit the washers back onto the 3 bolts. And then because there's only that one dowel, what I'm going to opt to do is to push the bolts through and then I'll get right down low so that I can look underneath and lower the whole thing in and hopefully get the alignment. First go. Here we go. And that's the 3 bolts all the way in. Again, you want to go reasonably even pressure all the way around. As you tighten them, don't welly on one, because that will throw the alignment over and make it more difficult to get the other 2 in. These are steel bolts going into aluminium, so you've got to be fairly cautious putting them together, but that should be all of that. And now there's no way to rotate this until you've fitted the motor and start the pump up. So that's why I wanted to make sure that it was turning freely by hand before assembling. So O-ring in place, the oil box can go back on, line that up, get some screws through there to hold that in place. And I've got the base plate and the handle to go on. But I'm going to place the motor on first, so that I'm not having to fight around the base plate and the handle to get it into position. Now these magnetic couplings have a hell of a snap to them as you put them together. When the magnets find each other, they really snap together, and they will crush your fingers. If I hold this like that with my fingers underneath there and drop it on, it's going to crush my fingers, so you've got to go pretty carefully with these. Fortunately, this is a nice light motor and easy to move around. The larger ones can give you real problems, but drop that in and you can feel it go. You see that grab. It's pretty much going to center itself, of course, but nevertheless, definitely be cautious fitting the magnetic motors. Those go in. Are we back to 5mm? Yes. They could have gone for 6mm, you see. They could have used the 6mm Allen key for the motor, just to make sure that every tool in the toolbox was getting a proper workout. It's not quite aligned. Give that a bit of a jiggle. Those two top bolts don't want to go in. I'm not going to put any pressure on them because, again, they're stainless fasteners going into aluminium threads. And as I've probably said before, I seem to say it a lot, the first thing that's going to give is the very expensive and hard to come by aluminium section, whereas the cheap and easily replaced stainless steel fastening will be absolutely fine. So if there's any sign that things aren't going together smoothly, stop and figure out why. That is the motor on. The base plate will sit up underneath. And then we can put it the right side up and get the handle on. It's bound to be the one that I need for this, isn't it? Oh no, look. 5mm can stay on the floor where it's decided it wants to live. Okay, handle's on, everything's back together except for the sight glass. So I'm going to go and figure out how to get the sight glass to go back through the hole with its bung, and then I'll put some oil in the pump, put it on test, and I'll just add a little clip showing you the results. But that's how to put that back together. So there is our Agilent DS40M vacuum pump, right down at full vacuum. It's very quiet, lovely little pump now that it's up and running. Couple of follow-up things. I did refit the sight glass there, It turns out that my first approach was the right one to use. Assemble everything into the rubber bung and then bung the bung into the pump. That got it in the end. It was very reluctant to start up when I put it onto the test bench. I knew it was turning freely by hand, so I didn't think the pump itself was sticking. Checked the running capacitor in the terminal box back here, and that was measuring exactly what it should be. So it comes down to what sometimes happens with these very small pumps. I had to switch it over to a thinner oil. I would normally put the grade 19 into the pumps. In this instance, I switched it back to this grade 15. This one happens to be Edwards. Grade 15 is a lower viscosity, so it's easier for the pump to turn over. And I also then had to go and warm it up in front of the heater for an hour or so, just to take the chill off it. It's about 6 degrees in the workshop at the moment, so it was just a bit too cold. The very small motor on here just wasn't enough to kick it over. Once it was warmed up with the lower viscosity oil, it started up without too much trouble and is now running lovely. It'll never get that cold in the lab that it's going into, so it won't be a problem for them, same as it is here. Anyway, there it is done. If you need any help with your vac pump, get in touch with me. The information is in the description of the video. Be pleased to hear from you.